Hello students, today we'll see a problem on Turing machine. So today we'll see the problem, design a Turing machine to accept the following language 0 to the power of n, 1 to the power of n, such that n is greater than or equal to 1. It is a non-regular languages. We have seen in the first problem itself that for this, we are not able to construct a finite state machine. If you remember, for this example, we are not able to construct a finite state machine. But however, we can construct a Turing machine for this given language. It is given that the language accepted by the Turing machine should have the number of zeros followed by number of ones. That is, which shows that it should have equal number of zeros and ones. But again, the another condition is it should be zeros followed by ones. So we'll take an example to explain this, how the Turing machine works for this problem. I have considered the example string w is equal to 0, 0, 1, 1. If you see this example, there are equal number of zeros and ones. What we'll do, initially we say that let Q0 be the start state. We see here, as we know, Q0 is the start state. The input symbol to be scanned is 0. So what does it does? The read-write head points to the 0 and it will check Q0 on 0. What it has to, what action has to be performed? We say that replace leftmost to 0 by x. We have here leftmost to 0 by x and change the state to Q1 and move the read-write head towards the right. Why we are doing this one? Because after reading 0, after reading and replacing 0 by x, we have to replace the corresponding 1 so that the number of zeros matches with the number of ones. That is, see, we have started with the initial state Q0 and 0 has been read, and after reading the 0, what does our transition says is change the state to Q1, replace the 0 by x. See here, Q0 on 0. So we are changing the state to Q1. We are asking to replace 0 by x and move the cursor to right direction. Why we are doing this one? After reading 0, we have to find 1, 1. So that's why we are moving the cursor to right direction. See here, if you check here, 0 has been replaced by x and the cursor has been moved to right direction. Currently, you are in which state? You are in the state Q1. When you are in the state Q1 and input is 0, what we say here, see, after reading 0, we are replaced x. When you are in the state Q0 and input is 0, we are telling that change the state to Q1, replace 0 by x and move the cursor to right direction. So same thing we have done. We are replaced 0 by x and remaining are as it is, and our state is changed to Q1 and we are moving the cursor to right direction. Until what we have to move, until we find 1, the Q1 just goes on moving to the right direction, keeping 0 as it is. So can you guess what will be the next state, the next transition? What is there here? You are in the state Q1. What is the input? Input is 0. What we need to do, if we are in the state Q1, input is 0, you should not perform any operation. You be in the state Q1 itself. Let 0 be as it is. Just I have to move the cursor to the right direction. Until what I have to move the cursor to the right direction? Until I am going to find 1. So once I find 1, which indicates that for 1, 0, 1, 1 is found. So for that purpose, I need to write the transition here. That is, if we are in the state Q1 and input is 0, we are telling let Q1 be as it is, let 0 be as it is, move the cursor to a right direction. So now can you guess where will the cursor? Cursor will be pointing to the next step. That is, here it is going to point. If you check here in the next step, it is x 0, 1. In the next step, the cursor will be pointing to 1. When Q1 is pointing to 1, what we are telling, if Q1 is pointing to 1, we are going to tell that change the state to Q2. Change the state to Q2, replace 1 by y, move the cursor to left direction. Why we are moving the cursor to the left direction? Again, for 1, 0, 1, 1 is found. Again, we are going to move the cursor to the left direction until we find 0. Until x is found, it is going to move in the left direction itself. So the next transition is If we have seen in the state Q1, we have to obtain the leftmost one and replace it by 1. We had done. So let us move the pointer to the leftmost one. When the pointer is moved towards 1, what we are going to do? The symbol encountered may be 0 and Y. Irrespective what is the symbol encountered, replace 0 by 0, Y by Y, remain in the state Q1 itself and move the cursor to the right direction. See here. What I mean to say is, now you are done. You have moved the transitions. You have performed this operation. Again, we'll go in the backward direction. That is, I'll go in the reverse direction. Move the cursor to left direction. Why we are moving the cursor to the left direction is, now 1 0 1 1 is found. Again, I'll go and check whether any more zeros are there. So here, the cursor has been moved. If you check here, delta Q1 1, change the state to Q2. You have changed the state to Q2. You have moved the cursor to, let Y be as it is, move the cursor to left direction. The cursor has been moved to left direction. So the state has been changed to Q2. Check here, you are in the state Q2. If you are in the state Q2, input is 0, what it has to do? See, when you are in the state Q0 and input is 0, then only I have to perform the operation. Now you are in the state Q2, input is 0. Any operation has to be, anything has to be performed? No, nothing. What I have to do? Let the Q2 be as it is, let 0 be as it is, just move the cursor to left direction. So what we say here, Q2 as it is, so this should be Q2 on 0 is 0 only, it's not Y, it is 0 only. If you are in the state Q2, input is 0, be in the state Q2 itself, let 0 be as it is, move the cursor to left direction. See why it is, say, I'll tell you, 0, 0, 1, 1, 1 is there. If you assume like this, first you are here, you are replaced this one. Then you have come here, this has been replaced. Then what we are doing, I am going into the left direction. Here is 0 is there. Again, here is 0 is there. Here it is, X is there. So what we say is, after finding this 1, 1, I'll just go on moving the cursor to the left direction until what? I'll move to the cursor to the left direction until X is found, which indicates that until that the zeros are red. After that, again, there may be more zeros. So what we'll do after changing this one, you'll go on moving the cursor to left direction. That is, you will be in the state Q2. You'll move the cursor to the left direction until X is found. That is, if you are in the state Q2, input is 0. See, check here. If you are in the state Q2, input is 0. Be in the state Q2 itself. Let 0 be as it is. Move the cursor to left direction. It will go on moving until what it is going to move, until the Q2 is going to find in the X. So if Q2 finds X, what we need to do, if you are in the state Q2 and input is X, see, up to this, what does it indicate? As soon as Q2 is reading X, which indicates that until up to that point 0 is right. Now we are in the state Q2. Yeah, input is X. So what we need to do, just you be in the Q2 itself, change the state to Q0 and let X be as it is, move the cursor to a right direction. Check here. You are in the state Q2, X as it is, move the cursor to a right direction. Q2, change the state to Q0, let X be as it is, move the cursor to right direction. When I'm moving the cursor to the right direction, then in the next step, the cursor will be pointing to 0. Check here. Now, Q2, Q0, 0. So this is Q2. This is Q0. Q2 on X. Q0 on 0, what we need to do? We have seen in the last step itself, Q0 on 0 is change the state to Q1, replace 0 by X, move the cursor to right direction using delta Q0. Why I have written here is in the previous step only we have solved. Here, if you are in the state Q0, input is 0, we are telling that change the state to Q1, replace 0 by X, move the cursor to right direction. We have moved the cursor to right direction. Now currently which state you are? You are in the state Q1. If you are in the state Q1 and input is Y, which indicates that when as soon as Q1 on input Y comes, which indicates that until that the zeros are red. So Q1 on Y, what it has to do? It should not do anything, just move the cursor to a right direction. See, you have seen, if you remember in the previous step, I have shown you. Here, if you check here if you check, Q1 on 1 only, it has to change the state to Q2 and replace 1 by 1, move the cursor to left direction. Similarly, on same steps, now if you check, If you are in the state Q1, input is Y, we say that be in the state Q1 itself, let Y be as it is, move the cursor to right direction. The cursor will be moved to right direction. That is Q1 will be pointing to 1. Now, if Q1 points to 1, we already defined the transition that Q1, if it Q1 on input 1, what we need to do, change the state to Q2, let 1 be replaced by Y, move the cursor to left direction. This 1 will be replaced by 1 and move the cursor to left direction. The cursor is moved to the left direction. Again, you are in the state Q2. Y is there. We say that you be in the state Q2 itself, let Y be as it is, move the cursor to left direction. As soon as Q2 on X, we have seen in the first step itself, Q2, if Q2 on input X, what it has to do, change the state to Q0, let X be as it is, move the cursor to right direction. See, Q2X, change the state to Q0, let X be as it is, move the cursor to right direction. See, up to these zeros are red. Again, we are asking the move to the cursor to right direction. Now you are in which state? You are in the state Q2. You are in the state Q0. Q2 on X, we change the state to Q0, X as it is, move the cursor to right direction. The state has been changed to Q0, X as it is, moving the cursor to right direction. Q0 on 0 we have defined, because that time we are told that if you are in the state Q0 and input is 0, we are changing the state to Q1, replacing 0 by X and moving the cursor to right direction. Now you are in the state Q0 and input is Y. What does it indicate? As soon as you are in the state Q0 and input is Y, which indicates that all the zeros in the left hand side are red. So Q0 on 0 is the change the state to Q1, but now it is Q0 on Y. What I need to do? If you are in the state Q0 and input is Y, which indicates all the zeros are red, we are telling that change the state to Q3, left Y be as it is, move the cursor to a right direction. So we are moving the cursor to a right direction, which indicates that here it is changed to Q3. Here it is changed to Q3 and the cursor has been moved to the right direction. Now you are in the state Q3, input is Y. What we are telling? You be in the state Q3 itself, let Y be as it is, move the cursor to a right direction. The cursor is moved to the right direction. As when Q3 and if the blank space is encountered, B is encountered, which indicates that all the inputs are red. If you are in the state Q3 and blank B is there, then we say that to change the state to Q4 and replace. Then B as it is, move the cursor to a right direction, where Q4 is the final state and the final configuration you are going to get is Q4. So if you go on saying, as I said, the tape, it is of infinite length. So further it is going to be filled with the blank character itself. So these are the transitions defined. Now, if you see all the 7 tuples of our Turing machines, Q is equal to, we had 4 states, Q0, Q1, Q2, Q3, Q4. Sigma is equal to 0, 1 and tau is equal to 0, 1. We are going to replace by means what all tape symbols, what all the tape is going to consist of, that has to be written in the tau. Tau is equal to 0, 1, X, Y and blank character. Delta is shown in the form of a transition table and Q0 is a start state. B indicates the blank character. Final state is the Q4. Here transition table is constructed here. Q0 on 0, we have defined what all we have defined here. Now, those I have shown in the form of a table. So write all the states Q0, Q1, Q2, Q3, Q4, and 0 are the 0 and 1 are the inputs. X and Y are the input symbols which you are going to replace zeros and ones, and B indicates the blank character. If we check the transitions, what we have defined? Q0 on 0, we say that Q1 XR. Check here. Q0 on 0 is Q1 XR. According to that only we are going to write. See here. Q0 on 0 is Q1 XR, which how do we read this one? If you are in the state Q0 and input is 0, we say that change the state to Q1 and 0 to be replaced by X and move the cursor to right direction. If you are in the Q0 and input is 1, the transition is not defined. If that is the case, we are going to put dash in the transition table. Q0 on X is there, no transition is defined, dash. Q0 on Y, we say that change the state to Q3, replace, let Y be as it is, move the cursor to right direction. Similarly, if you are in the state Q1 and input is 0, we say that the change the state to Q1, let 0 be as it is, move the cursor to right directions. What all transitions are there? Which state, what input, what action it has to perform, that is mentioned in the transition table. Based on this, the control unit will perform the action. So the transition diagram for this is, as we know that there are how many states are there? 4 states are there: Q0, Q1, Q2, Q3, Q4 are the states. So Q0 is a start state. Q0 on 0. See, if you check the table or the things defined in the transition table, just check it out. Q0 on 0, what is it indicates? Q1 XR means it has to go to the state Q1, 0 has to be replaced by X and move the cursor to right direction. So input is X, move the cursor to right direction. Similarly, what all transitions we have defined, those should be shown in the form of a transition diagram. So that we are going to show in the form of a transition diagram. This is how we are going to construct the transition diagram for the given problem. L is